My name is Jesse Garland, and this is the creative component for my senior project. I'm going to calculate the heat gained by water from burning a candle.
This is an electronic scale. We need the mass of the candle, and we also need the mass of the tray here so it can catch any droppings when we burn the candle. We can use this to find the actual heat gained and lost by the water when we burn the candle. And the mass is 20.51 grams. And this is the equation we're going to actually use in the experiment. Q equals mc delta T. The Q is actually what we're trying to find here. It is the actual heat gained and lost. It's equal to the mass of the candle multiplied by the specific heat of water, which is C, and then multiplied again by the change in temperature, or delta T. We burn the candle so we can get this change in temperature, because otherwise this Q wouldn't change.
And these are the actual tools we're going to be using for the experiment. This is the candle that we mentioned before. And this is another much larger can. Right here, this is what we're going to use to keep the heat from actually escaping into the room, so we can direct it towards our can of water. And it's going to go together simply like that.
This is what it looks like from the top. As you can see, the candle will burn, releasing all of its heat into our water right here.
Now let's get started. And now we wait. The greater the change in temperature, the better results we'll get. So, right now we've been burning only for 3 minutes, but we only use a very small quantity of water, about 50 milliliters. So, at this point, the change in temperature is drastic. So let's first blow out the candle so we don't gain any more heat. And we'll measure that volume later. And the change in temperature we have with this water, we have went from 22 degrees Celsius, which was our initial temperature, and we are now at 60 degrees Celsius.
And now we go back to the scale. We burn the candle, but we need to find exactly how much mass the candle has now, because it has changed after burning it. The candle is now 28.54 grams. That's actually higher than the actual candle itself, because I forgot to get the mass with this can thing on it. The initial mass was actually 28.81 grams, rather than the 20.51 grams we got before. And now we go back to our equation. We are going to find the energy gained from the mass of the water times the specific heat of the water times the change in temperature, which we got from burning the candle. So right now, the mass of the water itself was 24.33 grams. The specific heat of water is 4.184, and this is in joules per gram degrees Celsius. And then we find the change in temperature. Our initial temperature was 22 degrees Celsius, and our final temperature was 60 degrees Celsius, meaning that we gained 38 degrees Celsius. So we multiply this all together, and we go to our trusty calculator. So to find the Q, we first go ahead and take the 24 we multiply this by the specific heat of water, and then you multiply it by the change in temperature, and this gives us our Q. So our Q is 3,868. We cannot use any of these because of significant figures. And we can only have 4 significant figures in this equation. So now we have this magic number determined only by the water, the mass of the water, specific heat of the water. What did we need to actually weigh the candle for? Get the mass of the candle? Well, that's because we actually don't know how much heat is given off per gram, how much energy is given off per gram of candle burned. So we have this number right now, which is our Q. And we divide this number by the loss of mass in the candle. Now the loss of mass in the candle was not that significant. We only lost 0.27 grams of candle. That is not a lot, but that translates into a lot of energy being given off. And we go to our handy dandy calculator. So we take 3868 and we divide this by 0.27. And that's how many joules of heat is gained per gram of water. That is 14,325 joules per gram given off by the candle. And that's how you calculate the heat and energy given off by a candle.